page. So log base of 6 of m cubed, remember we changed that, divided by n to the 1/2 power. Alright, now see how we have a rational exponent? I want you to go ahead and fix that into a radical, just as a little practice on rational exponents, as a little refresher. So this is going to be log base of 6 of m cubed over, okay, if I want to change this rational exponent to a radical, anything to the 1/2 power is the same thing as square rooting it. Okay, like I said before, the exponent, which here would be a sneaky 1, goes in the numerator. My root goes in the denominator. So you can see how the square root of n is the same thing as n to the 1/2 power. Okay, so that's my final answer. Okay, number 7, just like your order of operations, you want to do the parentheses part first. So here, let's see, we're adding. If we want to condense them, we're going to be multiplying. So it'll be log base of 2 of 4 times x, so 4x. Alright, and I'm going to bring the first part down, 3 log base of 2 of x minus log base of 2 of 4x. Alright, and I like to go ahead and change that number in front to an exponent. So this 3 will move to an exponent and it will be x cubed here. Alright, last thing we can do to condense it, we're subtracting. So if we want to simplify this, we're going to divide those two. So it'll be x cubed divided by 4x. But go ahead and take this stuff one step at a time. A lot of little mistakes happen whenever you try to do it in your head or you try to skip ahead or something like that. So don't be afraid to write down every single step. Alright, number 8. Number 8 looks kind of bad, but it really isn't. Like I said, if you just take it one step at a time, it's not that bad. So we have 2 parentheses, log base of 3 of 32 minus log base of 3 of 8, close parentheses, plus 1/3 log base of 3 of 1 over 64. So we're going to do what's in parentheses first. And in parentheses we're subtracting. So if we want to condense it, we're going to divide. So log base of 3 of 32 divided by 8. Now, since we don't have any variables here, we can actually figure out what 32 divided by 8 is. And 32 divided by 8 is 4. So let's go ahead and do that. So what's in parentheses is log base of 3 of 4. Now, I'm going to bring everything else down. So the 2 in front, I'm going to keep it in front. And then at the end, we have plus 1/3 log base of 3 of 1 over 64. Alright, so next thing I like to do is change my number in front to an exponent. So this would be 4 squared. This one would be 1 over 64 to the 1/3 power. I just moved my number in front to the exponent. Okay, and we're adding these two. So if we want to condense it, we want to multiply it. Alright, so it's going to be log base of 3 of 4 squared times 1 over 64 to the 1/3 power. Okay. Just like before with the parentheses, since we don't have any variables here, we can go ahead and multiply those two and see what we get. So punch it in your calculator. We have parentheses 4 squared, close parentheses, parentheses 1 over 64, close your parentheses, and then press caret 1/3. And that 1/3 should be in the exponent. It should be a little number at the top. So I'll give you a couple of seconds to punch that in. Make sure you know how to punch this in because you're about to do this stuff on your own. Okay, and you should get 4. So my final answer is log base of 3 of 4. So you can see we really condensed this one. Went from this big long expression and condensed it to log base of 3 of 4. Alright, on the next page, is all about changing the base. So I talked to you yesterday about how your calculator will do logs, but it only does logs with a base of 10. So you can't put in log base of 3 of 4 and get an answer like you should. But you can. You just have to know how to change the base. So that formula is on there for you on your notes on that last page. And the formula is, let's see, log base of a of x. So let's say you have a different base, we'll call it a, and you want to change it to a base of 10 so you can put it in your calculator. So what you do is you take the log, and that would be a base of 10. Log base of 10 of x divided by the log base of 10 of whatever that base was in the beginning. Okay, so you divide them. So let's try this out. Let's do number 9. We're actually going to get an answer. You'll get a decimal, but you'll actually get an answer in your calculator. And it says we're going to round to 3 decimal places. Okay, so number 9, we have log base of 2 of 25. And let's say they ask for an exact answer. What you're going to do is in your calculator, you're going to do the log of 25 divided by the log of 2. Okay, so go ahead and punch that in. Log of 25, you're going to have to close the parentheses after the 25 or else it will not work. I see this mistake all the time. Okay, log of 25, close your parentheses, divided by log of 2. Okay, if you don't close your parentheses, it will be wrong. Alright, and if we round to 3 decimal places, you should get 4.644. Okay, if you didn't get that, you need to check your calculator. Make sure your parentheses are right, you divided, all that. And if you're kind of lost on where the log button is, the log button is on the left side of your calculator, kind of towards the bottom-ish, bottom half. It says log on it. So, let's try number 10. On 10, we have log base of 5 of 12. Okay, and we want an exact answer. But you can't put log base of 5 in your calculator. So, what you have to do is take the log of 12 and go ahead and write those parentheses divided by the log of 5. So punch that in your calculator. Let's see, and you should get 1.544. Alright, so I'm going to give y'all about 45 seconds to do the last two. It's not a whole lot of time, but really it's just punching in the calculator. And then we'll check. Okay? Okay, on number 11, you should have put in log of 5 divided by log of 0.5. And if you round to 3 decimal places, you get negative 2.322. Okay, so you can get a negative number whenever you evaluate logs. That's fine. Now, number 12, this one's different. You should have gotten an error whenever you punch this in. You cannot take a log of a negative number. Okay? And if you think about the reason why you can't, well, okay, let's go ahead and write that this is not possible. And you're going to need to remember this for later. Because we'll be solving logarithmic equations, we'll be solving for variables later. So this is something that's good to know. The reason we can't find the log of a negative number is because, let's say we have, let's go ahead and do this problem. Log base of 2 of negative 4. Let's change it to exponential. To me, that's a little bit easier to understand than logs. So let's see, we have log base of 2 of negative 4. If we want to change this to exponential form like we did yesterday, it would be 2 to the I don't know what x equals negative 4. Okay. So think about your exponential function. We went over how to graph those. I think it was last Friday, where you get this exponential function that looks like this. Okay, and you have a horizontal asymptote at 0. You can't get a negative number no matter what exponent you have here, as long as your base is positive. Now, if I have negative 2 as a base, then yeah, I can get a negative number, because if I do negative 2 cubed, it's like saying negative 2 times negative 2 times negative 2, right? So negative 2 times negative 2 is 4. 4 times negative 2 would give me negative 8. So, yes, in that way, you can get a negative number. There is no way to get a negative number if we have a positive base. I mean, it's just not possible. I could multiply 2 times itself a million times, and there's no way I can get a negative number. So, that's why this problem is not possible. You would have to have a negative base on your log to get a negative number there. So, just so you know. So, this is really crucial in solving logarithmic functions. So, we definitely need to practice it. If y'all need help, y'all can email me. If y'all need help, look back at the videos if you need to refresh on the laws. But it's going to be very difficult to move on to the next thing we're going to learn if you don't understand the laws of logarithms. Alright, so have a good day.